Okay, we're going to start by looking at solving a power equations, and then we're going to move on to quadratics. Let's go through these. So, if we have a power with the variable and we want to get rid of that, and we have it isolated like this, it's very easy. Yes, we can just cube root both sides. Of course, a cube root and a cube, opposite operations will cancel. Make sure you do the same thing to both sides. Is it possible to get the cube root of a negative number? Yes. 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 If the power is odd, we're okay. Yeah. If the power is even, that's a matter for discussion when we get to complex numbers. So it's -3. Is it plus or minus -3? Yeah, it can only be minus or negative. It cannot be plus. Otherwise, that answer would have been plus 27. Yes. Okay. What about one like this? What would be your first step?
Square it. I mean, to the power 5.
Yeah, a fifth rooted. Yeah, so these are all set up kind of ready to, well, the first two are ready to get a root. This one is going to be the fifth root to get rid of that, and a fifth root of 11, which is okay. Your calculator can do that if required. And we have x minus 2 is equal to the fifth root of 11. Now, is that plus or minus? No. I'm not going to ask you for the answer, but you know the way sometimes when you get the square root of 4, it's plus or minus. Put away the calculators. Square root of 4 is definitely, could be plus or minus 2. Yes, because, why? Because minus 2 squared is 4, and positive 2 squared is 4. Yeah? All right, so now we're at uneven number, yes. So is it plus or minus? You sure?
Yeah, if it's an uneven number, it can't be. No, it can't be. No, I mean the square root of the square. What's called the root is. If it's a fifth root of it, it's isn't every odd root able to be negative or positive in this case?
Maybe we'll do a simpler example, maybe. The cube root of 27 is a number we know. Is this plus or minus 3? Because minus 3 cubed is minus 27. And plus 3 cubed is positive 27. And that would work for the fifth root as well, wouldn't it? If it was minus. So this is just plus for the same reason as this. It would already be minus if it was minus, if that makes sense. Okay. So what do we do to finish this one here? We want to isolate the x, so you can add 2 to both sides, 2 plus the fifth root of 11. Okay? This, if you didn't have your calculator, that was how you'd finish that question. The next one, I'd be interested to hear your ideas.
In the example, they actually asked us to simplify that, or we just leave it like that?
That's as simple as you can get it. No, they're not going to ask you for the fifth root. That's a waste of time. You'd be all day trying to get something like that. Okay, question 3 there. So you're saying put 1 over x to the power 5. That's a good idea. Well, you have an equivalent statement here. So that means any part of it should, the same parts should equal each other. So you could say at this stage, if you have an equivalent statement, I can say that this, is that true? Yeah, because the denominator should equal the denominator. If the numerator is about 1, then, right. What do I do from this stage?
You just 5 roots. I was thinking cubic.
Fifth, okay. The fifth root of -32 is what?
Negative 2.
Okay, yeah. All right, that's some power equations that if you had to solve, you now hopefully can do a better job at solving. I'll give you some of those for homework. Yeah.
Is it fifth root or does it have a fancy name?
No, it just says fifth root, yeah. Okay, let's talk about quadratics, which is where I really wanted to go today. Let's look at, first of all, are we solid at solving quadratics? So we'll start with that. Okay, a couple of things. What shape is a quadratic?
Parabola.
Parabola, yeah, either happy face, sad face. What determines if it's happy or sad? Yeah, a positive or negative what? Yeah, okay, the x squared, yeah, so, or minus x squared, yeah, the a is correct. When we solve a quadratic, what are we getting?
Two different x values.
The zeros, two different x values. Graphically speaking, what does that mean? Oh, yeah, x-intercepts. So we're trying to find the x-intercepts, the roots of a quadratic it's called sometimes, because where it crosses, it kind of looks like the soil and the roots. Or the zeros because y will be 0. They're called zeros, roots, solutions sometimes. There's multiple names for them. Okay, that's what we're going to find when we're solving quadratics. Let's look at actually solving then. We got a few examples I want to get through here. 4x squared plus 1 is equal to 4x. Recognized as a quadratic because it's got sometimes called a trinomial, tri for 3 terms. 4x squared, we got a x squared term, we got an x term, and we got a constant term. What would I do here first step?
Minus 4x.
Yeah, okay. We want to bring everything to find the zeros. The y part of it must be equal to 0. So we have a subtract 4x. Okay. Now we'd have to be able to
You multiply
factorize. Is that where you're going with this? I want to get factorizing done.
The x method.
You may have your own method. I have a different method. Yeah, mine's more trial and error, more by looking at it. Yeah. I'm going to pick 2x and 2x here. Because if I pick 4 and x, that means the middle number will probably end up odd, because one is odd, the other is even. So now they're both even, and even in the middle. And then I go 1 and 1. That's the only thing. And the signs would be, I do this little test, 2x multiply. They both must be both negative in order to do that. Now you have a different method. You surely have a method at this stage. I'll do that again slower with a second example.
Isn't it meant to be minus 2x?
Yeah, they both have to be minus.
Negative 2x minus
No, it's not.
negative 4x.
Am I right? Now I haven't finished this. Sorry, I was about to move on to a different example. Do we know how to finish here using null?
2x minus 1.
Null factor law. If they multiply to give 0, they both must individually be 0. So 2x is equal to 1x is a half. So when there's only one answer, what's that called?
Yeah,
It does have a special. It's called a repeated root. It's called a repeated, or the x-axis is a tangent if you want to think about it that way. So, okay.
Oh, if both x's are the same, it's a repeated root.
Yeah. Okay. So let's do another one. I'll give you a second to do this one before me. I'm going to do this one. This is a tricky one. See, can you get a solution for this yourself?
So you just do this trial and error.
I would do a trial and error. You might have a different method from Mr. Benson or Mr. Gide.
I don't know the x. I looked at like 15 times.
I mean, it's more. Yeah, just try it out.
It's just don't be mind injuries.
You all have a method, or do you want me to do it? No, that's not going to work. 8 and 7 is not going to work here, is it? No, start again.
It's gonna be 13. Oh no, that's 52.
I'm so long. What about Ryan? Adds to multiplies to 15. Yes. No.
So 15 can go a number of ways. 5 times 3, 15 times 1. This can go a number of ways too. 8 times 7 is the obvious one.
X method. I'm doing the x method.
No, this would be without a calculator.
What times what?
Try not to use a calculator. 4 times something, though, could be our friend. 4 times.
17, no.
4 times. Well, if that one's half, this one's going to be doubled. Yeah, 4 times 14. Notice the relationship. Half that, double that. So 4 and 14 might work, actually. Yeah, do your method. Don't do my method. You have a method. This, you'd have to be able to do this without a calculator, yeah. You can check your answer in the calculator if you want. You can draw it.
Oh, it's gonna be. Yeah. It's 14.
So if you use 14 here and 3 here, does that work? Oh, not 3, 4. No.
I don't think it is 14.
No, it mightn't be. What's the other one then?
I think it's 8 and 7.
2 and 28 is a friend.
That's 2. I'm gonna do 8 and 7.
Well, 2 times 15 is 30. Has the X method worked for us yet?
The X method, no, but it would mean now we have to do it. Well, how much have you experienced?
Well, I'm not trying to multiply with the.
840.
Okay, I think I may have it on my third try. If I use 28 and 2, if this one is positive and that one is negative, I make the positive 2x in the middle, and it checks to make minus 56. So that was about as hard as it gets to do without a calculator. So 15x minus 28 equals 0. X is then 28 out of...
It takes a while to go on.
Yeah, yeah. Yes, it definitely does, yeah, yeah. So x is negative 2.
Is that like a way to do it without your calculator?
Well, this is... No, not really. There's the X method, which they can teach you. I don't use.
Yeah,
I use...
I've done that one, but you need to time both 15 and 56.
Yeah, you gotta try a lot of different ones, and you get a lot of answers you know are wrong. This one is, I look at the factors and I go, just what I did. Like usually you get it in the first or second go. This one's just a particularly tricky one because you're looking for.
This would what, be only like 2 marks?
Yeah. More than likely, it's just going to be part of the end of a question. A lot of questions in AA Maths finish with a quadratic. You factorize it, you get your solutions, and you interpret those solutions. But there's some stuff that's gone on before that. Yeah.
This being a non-calculator.
Yes.
Really?
Yes.
Oh, wow.
Okay. Do I need to do one more? Oh, let's do one more, just to. It's just got a slightly different setup, but hopefully you'll be able to deal with it. Okay, try that one. Okay, so this does come into a quadratic, which is your first test. Can you turn it into a quadratic before you go and solve it? If you're not sure what to do, multiply everything by x. So if I multiply this by x, multiply this by x, multiply by this by x, what do I get on the next line? I get a 3x squared. These x cancel. I get a plus 2, and I get a minus 7x. And then I rearrange, so I get my zeros by letting the y bit equal 0. Okay, and this should be an easier one than the last one, yeah. Hudson, what's your thoughts here for here and here? Well, there's only one option. Yeah. And then Does the 2 multiply with the 3, or is the 2 multiply with the 1? You want the 2 here, so it multiplies with the 3, and the 1 here. Because that'll make 6x, and that'll make 1x, and they have to be both positive. What am I doing when I do this thing? Does that make sense? Why am I doing this?
Yeah, I don't understand that.
Why do I do that?
So it's like free, like it's random.
Yeah, exactly. Hudson's nailed it. It's I am just shortcutting my expansion. If I was given this question to multiply this out, what would I do? I'd go, this times this gives 3x squared. This times this gives 6x. This times this gives 1x, or just x. And the last 2 gives 2. Now all I'm doing is these 2 multiplications and just testing they add to get the middle term. That's this test, because they multiply to give the middle term. Those 2 multiplications. That's what I'm doing. Okay. I'll give you some of those to work on for homework as well. Let's move on to something called completing the square, which sometimes is done in year 11. Do you remember completing the square? Not by. No.
I mean, I like Wait, is it wrong? No. If you have 3x minus 1 and x minus 2. Remember, I told you to do it.
That'll give them negative 7x in the middle. So you can't have a negative. So this is factorized. The answer to this is minus 1/3. And the answer to this is minus 2. Okay, that's the roots or the zeros of that equation. That's where it crosses the x-axis. Okay, completing the square. I'm going to give you the steps first, and then I'm going to use the steps in the example second. So I'm going to write the steps first, and then, so this will be what you always follow. I better make sure to get it right. I remember I got it wrong last year. Divide by a, move constant to the right-hand side.
What do you mean by square?
Completing the square. I'll explain what it means in a second. I'm just giving the steps, and then I'm going to do the example, and then it'll all come clear. Right-hand side. Okay. All right. All right, you take that down. That's the step-by-step process, and then we look at completing the square, what it is, and how it's useful. At IB level, yeah, usually. Some at GCSE and a few at year 7. Yeah.
Do you have lots of subscribers outside of school?
No. I don't want to either. Okay. Yeah. It's only recording me, not you're recording you. So you can't say anything. All right, so let's look. Dividing by a is already quite confusing. Completing the square, what's it about? It's about a quadratic. It's another way of solving a quadratic. So a quadratic is a general form of quadratic, as you probably have seen before. Dividing by the a directly refers to the coefficient of the x squared. So completing the square is a way of solving quadratic equations if you can't factorize. That's one thing it does. It can solve any quadratic equation, even if it doesn't have whole numbers or easy fractions as its roots. It'll always work, and that's good. And it's going to be, if it comes up, it'll be in paper 1, which is your non-calculator paper. Paper 2 and 3 you're allowed a calculator. So all this stuff is paper 1 stuff. Skills without a calculator. Because if you have a calculator, you can just draw it for a start. And you can just, oh, there's where across the x-axis, sweet. Okay, so I'm not going to use this example. I'm going to use an actual example. Here's one that perhaps I cannot factorize. Y is equal to x squared plus 4x. Is it plus 1? Yeah, I'm going to use this one. Yeah, so this is the quadratic equation. If I'm trying to find its solutions or roots or zeros, I would let that equal 0. So I'm going to solve this using completing the square. Now the first thing you notice, if you did start the brackets, open the brackets on both sides, you'll notice there's no way you can get 1 plus 1 to add to 4. So there must be, 1 must be broken up into decimal by a decimal to get to 1. But we're not sure what. And this will help us do it. So let's follow the steps. Divide by a. If a is 1, as it is in this case, we do not need to divide by anything. So this is quite a simple example. So that's step 1 done already. If a was 2, you divide everything by 2, so you'd get a down to 1. So if it was 3x squared plus 4x minus 7, your first step would be to do, oh, not cubed. Your first step would be to do this. Do you see what I've done? So this brings it down to 1. I divided this by 3, and the other 2 will not be as easy. Okay. Yeah, it's 0, so yeah. Okay, move the constant to the right-hand side. So we have a clear left-hand side, right-hand side of the equals here. The constant is this term. We agreed, and that moves or subtracts over to this side. So we've x squared plus 4x is equal to minus 1. Step 2 done. This is the whole key, this one. Step 3 is the whole key to getting it right. Add the coefficient of the x. In this case, it's 4. So 4 divided by 2 squared. What's that number? I'm just doing it as a bit of rough work here on the side. 4 divided by 2 is 2. Squared is 4. Add that to both sides. Okay. X squared plus 4x plus 4 minus 1 plus 4. So I haven't changed anything by adding the same number to both sides. That's okay. And then just factorize the left-hand side and finish. Okay, that's leaving a lot. But factorize the left-hand side. What we're looking for is a square. Perfect square. What's a square? The same side by the same side. So if this was 2, that'd be 2. 2 things multiplied together to get the area, that'd be 2 squared. In this case, it is not just a constant. What squares to form that? X plus 2. X plus 2 squared gives this. X plus 2 times x plus 2. So I have factorized. That is the square complete in a way. What does that equal? 3. And this is coming back to the start of the lesson. How do we finish a question like this? Square root both sides. X plus 2 is equal to the square root of 3. Is this plus or minus? Square root? Plus and minus. Could be either. If I get a square root, it could be plus or minus. A cube root, it's the one that it is. It's the sign that it is. X equals minus 2 plus or minus root 3. There are 2 answers. X can be minus 2 plus root 3, and x is minus 2 minus root 3. Root 3 is What type of number? Irrational, yeah. So that's why it would have been so hard to find the factors for 1. Do these two multiply together to give 1? They should, yeah.
Will it always become a square, like a perfect square?
Yes, this system makes it a perfect square. If you do this, the coefficient of x divided by 2 squared will give you a perfect square. Because what you're doing is you're forcing it in there.
How are you just like allowed to add something to the
You're allowed to add something to equation as long as you add the same to both sides. If you're solving a very simple algebraic equation, if I add 1 to both sides, I have not changed the equation. 5 still works here and works here. The same process here. I just added the same thing to both sides. I'm not changing anything. I'm balancing it. That's fine. I'm allowed to do that. Okay.
Where does the plus 4 go going from 1 step 3 to...
Here. This is the factorization. This is completing a square. This will always be a square. It'll be one bracket that is squareable.
Oh, okay, yeah.
It'll always be that. So another example would be x squared plus 6x plus 9. It'd be x plus 3 squared. Yeah.
How does x plus 2 squared equal to x squared plus 4?
Yeah, good question. So x plus 2 squared is x plus 2 times x plus 2. No, you're forgetting the rules of multiplication. You got to multiply everything by everything. So x times x is x squared, but you've got two x's in the middle. Okay.
So you're adding something so you can factorize it.
Boom. We only add this so we can factorize. And can factorize in a very special way a square. Now, if you think visually about this, what's the axis of symmetry of this quadratic? Axis of symmetry where it could fold over itself, where's the line where it folds? What's it going to be?
X equals 0.
You think?
Yeah. Yes.
Yes?
You're trying to check. Is it right?
So you think that it's perfectly situated either side of 0?
Yeah.
Wouldn't it be perfectly situated either side of minus 2? Be plus root 3 on one side and minus root 3 on the other side?
Yeah. Wait, are you still trying to check?
No.
Yes. Yeah. Up to minus 2.
Isn't minus 2 the middle of these two numbers? If you add root 3 on one side or minus root 3 on the other side, does it?
Yes, it does.
Yeah. So the middle, the axis of symmetry of this is minus 2. And this root is if I subtract root 3 from it, and this root is if I add root 3 to it. That'd be the two roots. So this gives us axis symmetry as well. Completing the square, the axis symmetry is in there, which you could easily get. Minus.
How do we just know that minus 2 is the middle?
We pretty much logicked it out. If you have
It was the same.
3 plus 2 and 3 minus 2, what's the middle of those two numbers? It's 3, yeah. So that's what. Okay. We're going to do one more example. I'm going to do one in theory. I'm actually going to use this one now. It's like a proof that it works. And then you're going to do something. Does it work every time? So this is for any equation with A, B, and C. Will it work? So the first thing I'm going to do, well, yes, but let's see what happens when we try it. We let it equal to 0, the same as we did the last time. Now this is where it gets a bit tricky. We divide by A. If I divide everything by A, this cancels, but these two are not very nice. I have B over A, x, plus C over A equals 0. Okay, you don't need to take this down, you can just watch. Move the constant to the right-hand side. Which one of those is the constant? C over A. So we've got x squared plus B over A is equal to negative C over A, yeah? All right, that's done. Now, the coefficient of the x divided by 2, I'm going to do this on the side again. B over A divided by 2, and then square that. Okay, What's that?
4b over a squared.
4b. Well, getting this bit right is b over a divided by 2. What is that? A fraction divided by a whole number.
You just times 2 and 1.
Just let's make sure. Let's do an example. What is a quarter divided by 2?
It's 1 over 8, so it'd be.
It's a quarter multiplied by a half, which is 1 over 8. So is it b over 2a?
Yeah.
All right. So it's this will apply to that. Okay.
Yeah.
So it's b over 2a, and then I have to square that. So that's b squared over 4a squared. Yes? What do I do with that? Add that to both sides. Oh, yes. This is great. This is what you signed up for HL Maths for. B squared, 4a squared. I added it to that side, and now I'm going to add that b squared over 4a squared to that side as well. Yuck. Factorize the left-hand side. Now, I know it factorized because we did it the last time, and it factorized a lot more visually easily. But I know that this factorized, that's the whole point of this. It will factorize. But what does it factorize to? So it's something, it's x something squared. What goes here? It's going to be plus. What goes here?
I don't get how you do this without the
B over 2.
They just have to.
B over. Is there an actual answer?
Yeah.
What?
Is it b over 2a, I heard? No?
Would it actually make sense?
Doesn't it?
B over 2a? No.
What's a half plus a half? 1. So the half goes away, the denominator becomes 1. This does work. We can multiply it out if you want. What you'll end up is b over 2a plus b over 2a with x. That'll be the middle term. They both have x. So that'll be 2b over 2a, which is b over a. That'll be the middle term. It does work. It'll always be this. It'll always be this. Will be there. This is there. See that? Because you're going to end up squaring it anyway.
Yeah, that's right.
Right. And that still equals minus c over a plus b squared over 4a squared. Okay. Before I square root this side, I'm going to combine it into one fraction. So I need a common denominator. So I'm going to pause this. I'm going to just rewrite this. And in a minute, I'll square root. But now I'm going to combine this. What's my common denominator? 4a squared. No, 4a squared. I don't need to cube it. This one then needs to be multiplied by 2a or 4a at the bottom and 4a at the top, yes? Minus 4ac plus b squared. Now, a lot of mathematicians don't like to start with the negative. They like to switch that. B squared minus 4ac. I'm just going to swap those around because it doesn't matter which order. You can write minus 3 plus 4. Or,
not 4ac squared.
because I only needed to multiply. I'll do it in a different color so we see that. I multiplied the bottom by 4a and the top by 4a. I didn't need to multiply by 4a squared. There's already an a there, yeah? Yeah. All right, now I need to square root. Yeah.
Where did 2a go for the x squared plus b over a? Why is, and then the next thing you're saying 2a.
Over here?
Yeah.
Okay, so this is the factorizing. We did this briefly. If this factor, it's always going to be a perfect square. This is a perfect square. So it factorizes to a perfect square, something squared. That's the whole point. That's why it was easier when it was 4x and you could see it. This one, if you multiply this out, I guarantee you by itself, and maybe we'll do it as another aside. If I square this out, it's this times itself. We'll get there. X times x is x squared. X times this is bx over 2a, yeah? This times this is also bx over 2a. And this times this is b squared all over 4a squared, yeah? So we have this and this. The middle term needs to be this, though.
Oh, x. Okay, I got confused by x.
So there's two b's. this becomes 2b over 2ax, and the 2's cancel. Does that make sense? Okay. All right.
I thought b over 2a times x is xb over 2a.
Okay. All right, let's finish this. We're almost there. I'm going to square root both sides. So this becomes x plus b over 2a. The square is gone. If I'm square rooting, I need to do plus minus, don't I? Square root this side, b squared minus 4ac, all over 4a squared. But I can't get the square root of the top, but I can get the square root of that. What's the square root of that? 2a. So I can remove the square root from that part. And then if I bring this over, x is equal to minus b. I want x equals. Plus or minus.
Oh, the formula.
Oh, it is the quadratic formula.
So that's how it works.
The quadratic formula works because it is completing the square in formulaic form.
How do they figure out this stuff? Like, do they just sit down for hours and just play with letters?
Pretty much. Well, it's a logical if it works for one, you test if it works for more, and then you test if it works in every case, and this is every case. They just did it for every case, and we got to the end of doing it for every case, you realize there's a formula. Hmm? The quadratic formula came from because the square root of something is always plus minus, unless there's a reason for it not to be. Good question. They're both over 2a. So I just combine them into one fraction. Separate. The first, okay, you can write it separately over 2a, but if they're both over 2a, it's the same. Yeah. Yeah, so if they're both over 4, you can just combine them in one fraction. Yeah. Right, so that the quadratic formula is, if you had a calculator, you would go straight to the coefficients and you just sub them into the quadratic formula. If you don't have a calculator, you would follow these processes for completing the square. Right. Now it's your turn.
Yeah, I got this.
No.